Hello and welcome to Textbook Engineering Problem, where we'll be working on Elementary Principles of Chemical Processes, 3rd edition. We're doing problem number 2.27. 2.27, we'll see the volume of a microbial culture is observed to increase according to the formula V, which is in centimeters cubed, e to the t. Okay, where t is a time in seconds. T is in seconds. Okay. Calculate the expression for volume in terms of time in hours. Okay, so we need to convert our time in seconds into time in hours. Well, it's a little tricky right here, but there is a coefficient here that you can't see, and that's because the coefficient is equal to 1. Okay, so if we change our expression to say 1 times e to the 1 times t, then that changes our expression. So there are two coefficients here. They're both equal to 1, and we'll say that this one is equal to A and this one is equal to B. Okay, so A equals 1 centimeter cubed. We need to convert that into inches because that's what the problem statement asked for. So there are 2.54 centimeters per inch. And so that equals 0.0610 inches cubed. We know that A is equal to the same units as the volume because this term cannot have any units. Exponents cannot have units. So e raised to the exponent has no units. That's why we know that there's a coefficient here, and that coefficient is equal to 1, and it has the same units as the volume does. So that's why we say 1 centimeter cubed is equal to A. Okay. Now we're converting our second coefficient, B. Well, we don't know what the units are of B, but we do know that B has to have the same, or has to have reciprocal units to what T has, and we know that T has seconds. So now we know that B has to have reciprocal seconds, or 1 over seconds. Okay, so B equals 1 over seconds, and we're converting this into hours. So there are 3,600 seconds in 1 hour. And this equals 3600 1 over h. Okay, so now our function looks like this. V equals A e to the b t. And that's our expression for part A. Part B, both the exponential function and its argument must be dimensionless. Okay, that's what we just said. It's saying that both the exponent and its argument must be dimensionless. That's what we just talked about. The given equation seems to violate both of these rules, and yet the equation is valid. Explain this paradox. Hint, observe the result of part A. Okay, so A and B are hidden because they're both equal to 1, but they're still there, like I explained. Right here and right here. So we basically explained part B. Those coefficients are still there even if they're hidden. So yeah, that's how you explain the paradox. When you change the function to A and B, instead of being in centimeters and seconds, A and B are not equal to 1, so they'll show up in the equation and you'll be able to see them visibly. Anyway, that is the answer to 2.27. Thanks for joining me. And if you have any questions about this, put them in the comments. If you have any problems that you would like me to check out that are part of this book, I can take a look at the problem. It doesn't have to be in chapter 2. And if I made any errors, let me know in the comments as well, and I'll try and post those as well. Thanks for joining me. Bye.